Hello and welcome to Mysteries of Science. My name's Stevie and I'm the Deputy Editor of Science+Nature, the monthly magazine from the team behind The Week Junior.
And I'm Michael, the Junior Editor. On this podcast, we take a look at our favourite mysteries of science. These are the strange phenomena and bizarre events that have left scientists scratching their heads and, despite their best efforts, remain well and truly unsolved.
This episode is being released on the 10th of June 2022, which is a big day for dinosaur fans.
Why's that, Stevie?
Well, the release of the latest Jurassic Park movie, of course. Well, not Jurassic Park, Jurassic World Dominion.
Of course, I love those films. Everything I know about dinosaurs comes from Jurassic Park and Jurassic World.
Well, Michael, I hate to break it to you, but as great as those movies are, they aren't always scientifically accurate. What if I told you that T-Rex might actually have had feathers? Or that some dinosaurs behave more like modern-day birds than the fearsome monsters shown on the screen?
Well, I'd be pretty surprised to hear that, but pretty interested too. I mean, how do we know all of this? How can scientists know what dinosaurs look like or how they behaved, considering they all went extinct 66 million years ago?
Well, let's go fossil hunting with some dino experts to find out. It's time for a podcast 66 million years in the making. This is Mysteries of Science.
So, Stevie, how do we know what dinosaurs look like?
Well, as you said, Michael, they went extinct 66 million years ago, but that doesn't mean that they disappeared without a trace. Remains of dinosaurs can be found preserved in stone all around the world. We call these remains fossils.
And it's some people's jobs to look for these fossils and study them, right?
Yes, we call these people paleontologists. These are scientists who study the history of life on Earth by looking at fossils.
Okay, so if we want to know what dinosaurs look like, then paleontologists are the people we need to speak to.
Absolutely. But if we're talking about paleontologists, then there's one person we have to talk about first, Mary Anning.
Mary Anning, now I've heard that name. Who was she?
Mary Anning was a pioneer of paleontology. She lived in Lyme Regis in Dorset, England from 1799 to 1847. And when she was about 12 years old, she discovered the first ichthyosaur. And around 12 years later, she discovered the first plesiosaurus fossils. Both of these were marine reptiles that lived during the age of the dinosaurs.
So it sounds like she was a pretty important person then.
She was. But until recently, not many people had heard of her. Around 5 years ago, a 10-year-old girl called Evie Swire started a campaign called Mary Anning Rocks. Evie wanted Mary to be honoured with a huge statue in her hometown of Lyme Regis, and finally this year the statue has been completed. So we spoke to Evie a week before the statue was unveiled to the public and asked her how she first found out about Mary Anning.
I first found out about Mary Anning in first school, so I think it was year 4. We were learning about her in class and just about fossils and just things that she'd learned about who she was. I just found it really interesting that a woman that had done all these remarkable things for us to know what we know about, like dinosaurs and what was here before us, doesn't have the recognition that she deserves to have. Like other people who have done sort of things like her you know about, but no one really knows who she is because she's been lost in history just because of like her gender and her class.
Learning about Mary inspired Evie to campaign for a statue of her, and after 5 years, her hard work has finally paid off.
That's amazing. So what does the statue look like?
The statue is Mary walking towards the sea, and it has her, this is my favourite part, she has her dog with her behind her called Trey. And it's just, she's just got like a normal thing she would have worn to go down and get the fossils and a little basket with her to put the fossils in, which is really nice.
So it's taken 5 years for the statue to be put up. So how did it feel when this dream finally became a reality?
It's just taking so long to do, and now that it's finally up, it just makes me really happy that it's finally finished and we've been able to do this even though there were so many obstacles in our way. I hope that when people see her statue, they'll be inspired and realise that she is an important person who should be known by a lot more people than she is known by, and I hope that it just inspires everyone to know even if you have these disadvantages in your life, you can't not do what you want to do.
Well said, and it sounds like we owe Mary Anning a lot for our knowledge of prehistoric life.
We sure do. Now we've spoken about one paleontologist from the past. How about we speak to a paleontologist from the present?
Hello there, my name is Cameron Scaly. I'm a self-taught paleontologist based in Atlanta, Georgia. I'm a paleontology educator, so I use the fossils and what I have to educate the community on paleontology and geology. I love dinosaurs. I loved dinosaurs as a kid, and I'm happy to do and talk about anything that has to involve dinosaurs.
So Cameron's love of dinosaurs was actually encouraged by one of his teachers at school who would show him their own fossil collection.
Sometimes in the morning I would go down to her classroom and we would talk about if the Loch Ness Monster was real and Bigfoot and also about dinosaurs. But she had her own personal fossil collection, and she had a collection of various different types of fossils. She had trilobites, she had plant fossils. She also had coprolite, which is fossilized dinosaur dung, or that particular dung belonged to a dinosaur. And so I remember going in there as a kid, and I've never actually, at that time, I didn't actually, dig up any fossils or anything like that. I've actually never seen a fossil besides the ones that I saw in the museum. And so this is like my first hands-on experience with fossils and be able to understand what they are. And they are actually the remains of ancient organisms that lived long ago.
Ooh, well, if Cameron wants to know more about the Loch Ness Monster or Bigfoot, he can check out some of our earlier episodes. But hang on a minute. Did he just say he had looked at fossilised dinosaur poo?
Yeah, so coprolites are the fossilised feces of animals that lived millions of years ago.
They're not too smelly, I hope.
Imagine a poo that's been preserved for millions of years.
Oh, anyway, moving on. Cameron said he was a self-taught paleontologist. How did he teach himself paleontology?
Yeah, good question. So I remember I spent hours and hours in the library. I didn't really grow up in an area where there were a lot of paleontologists. I didn't, get to meet any other famous paleontologists when I was growing up, like Bob Bacher or Jack Horner. I lived in an area where paleontology really wasn't that popular. So as a person who got interested in paleontology through dinosaurs, I began to really try to figure out, what dinosaurs were, how can I learn a lot about them. So I spent a lot of my time in the library reading on books about fossils and reading about books about geology and about not just dinosaurs, because dinosaurs are a small section of paleontology. So I began reading books on biology, geology, and even some things about chemistry, and really trying to have a good basis of what paleontology is.
Okay, so it sounds like Cameron is the perfect person for us to ask this question. How do we go from discovering these fossils in the ground to then understanding exactly what that dinosaur would have looked like and how it would have behaved?
Yes, and what do they use for reference? After all, it's not like they can look at pictures of dinosaurs taken back when they were alive.
What we want to do is try to look at modern animals. Sometimes we have fossil groups that are gone and are no longer extinct or that are no longer with us. And so we really have to use modern organisms related to some of those fossil groups in order for us to really understand what an organism would have looked like or would have acted like in life as it's extinct. So what we want to do is look at something like maybe, let's say, for an instance, a sauropod dinosaur. Giraffes and things of that nature have been a really good analog for looking at sauropod dinosaurs because of their long neck. They have a really similar kind of anatomy and feature.
Well, I'll never look at giraffes in the same way again. They're dinosaurs to me now.
I don't think that's exactly what he's saying, Michael, but looking at how different animals like giraffes evolved can help us understand dinosaurs better. Our next guest has studied all sorts of animals, but has a special place in his heart for dinosaurs.
Hi, I'm Professor Ben Garrett. I'm an evolutionary biologist, and I've been lucky enough to work around the world with animals such as chimpanzees in Africa, walruses in the Arctic, and sharks in the Caribbean. But for me, one of my favourite groups of all time are the dinosaurs.
So Ben said he's an evolutionary biologist. What is that?
This means I'm a particular type of scientist. I'm a biologist that studies how life changes over time. And I look at these processes that determine what causes these changes. So it might be from the smallest microbes you can imagine right up to the largest animals such as blue whales. And very often these processes are very slow and take a huge amount of time. But it might explain why different animals have wings, or certain plants smell like bodies, and how viruses change over time. So it's looking at the processes of life.
Ben's fascination with dinosaurs started when he found a fossil on the beach when he was a kid.
Ooh, I think I found my first fossil when I was 4 or 5 years old on a beach with my mum and dad, and it was that real sense of, wow, how old were these animals, these organisms? Where did they come from? Where do they go? And how do these bones and remains turn into stone over millions of years? So yes, I think it's fair to say I've always loved dinosaurs and other prehistoric animals.
Do you still have the fossil?
Oh, completely. I've still got the fossil. It looks like the lid of a pen. It's only very small. It doesn't look especially cool. It's not a tooth or anything. It's called a belemnite, and it's the little internal shell-like structure from what we call a cephalopod. These are the relatives of things like squid and octopuses, and this particular animal, this belemnite, was swimming around Norfolk, where I'm from in the UK, about 100 million years ago, so quite a long time ago. And remember, as a kid, that was amazing for me.
Ben's love of dinosaurs led him to write books about them. These books include So You Think You Know About Dinosaurs series and Extinct.
I really wanted to write these books because growing up, I didn't feel that, for me at least, the resources were there in a handy format that I could take these sorts of books out with me onto the beaches or into forests or wherever, even into school as a kid. So I wanted to write a series of books that young science enthusiasts could take with them. And it went from So You Think You Know About Dinosaurs into my more recent series, Extinct, as well. And it's the same sort of idea, I want really good high-level science, really up-to-date science in a fun, engaging and visual fun method as well.
Writing these books, Ben learned that everything you think you know about dinosaurs is wrong.
What does he mean, everything?
So, in many ways, our traditional understanding of dinosaurs has completely changed. If I asked you right now, if you're sitting at home or wherever you are, to close your eyes and just for a couple of seconds imagine a big predatory dinosaur. You can imagine the head high off the ground, the tail dragging along the floor, green, scaly skin, roaring like a classic dinosaur. Yeah, none of that is actually true, we now think. We've almost given many of the dinosaurs a bit of a makeover, but we've used science, so we know what this updated vision of these animals would have looked like. And actually, rather than the tail dragging along the floor and the head high up in the sky, the tail would have been off the floor, it would have been raised, and that would have given it more balance and would have allowed the animal to move in a much more agile way. The head would have been closer to the ground, suddenly in that danger zone. That's the area you don't want to be in if you're a prey animal. And even the skin itself. We know that dinosaurs weren't reptiles in the same way that lizards and snakes and crocodiles and turtles are today. They were a whole different group, and we've gone further than that. We've actually seen that in many instances, many of the theropods, these big predatory dinosaurs, were feathered in many ways. And that was right across the board. So not just the big ones, actually, it was the small ones as well. Things like Microraptor and Anchiornis. These were small feathered dinosaurs, but right up to even potentially some of the big iconic ones, such as T-Rex. They weren't scaly lizard-like animals. They may have been feathered, and we can even go further than that. So looking at Anchiornis, it was this small black and white animal with feathers, almost like a magpie, with this big red section around its face. Microraptor would have been this oily black sheen to its feathers, a little bit like a starling today. So we're seeing colours and patterns and body coverings in a way that we never saw before.
Okay, but what about the roar? I mean, dinosaurs still roared, right?
There is tentative evidence that dinosaurs didn't roar. That's a very much an artistic license thing there. We've taken this idea that, yeah, they were big, they were iconic, they were scary, we reckon they probably roared. The evidence suggests otherwise, and they might have sounded a bit more like some of the birds alive today.
So if you want to hear what a dinosaur sounded like, don't watch Jurassic Park. Listen to some birds instead.
But how have we found all this out? I mean, what's allowed us to come to this more complete, more realistic picture of what dinosaurs actually looked and sounded like?
It's a combination of two things, really. So we are making, I think it's fair to say, more discoveries now than we've had at almost any other point since the inception and discovery of dinosaurs as a group. On average, we're describing and naming about one new species a week at the moment. And even recently, there's a whole new Spinosaurid relative from Spain called Iberospinus. So even the big, iconic dinosaurs are coming in thick and fast. So first of all is more discoveries are coming in, and with that we're finding even little fossils like feathers with patterns on that are really important parts of this bigger picture of what dinosaurs were like. But also the technology is changing as well. So imagine 10 or 15 years ago, and you'd found this wonderful fossil bone. If you wanted to look inside to see what the internal structure was like, you'd often have to crack it open or saw it in half. That's not great because it ruins the fossil. Whereas now we can use laser scanners, we can use CT scanners, we can do 3D printing, we can do all these wonderful things by having improved and better technology in many ways. When you look at things like the feathers, for example, you can use these huge, very expensive microscopes called scanning electron microscopes, and they can look at they can look at these tiny structures on the feathers of these fossilized pieces of the dinosaurs' coverings and see what the patterns were like, and even predict what the colours were like on these feathers as well. So there's a lot of complex but really interesting science going into this right now.
So not only are we making new discoveries all the time, new fossils lying in the ground, but also developments in technology mean we can look at these fossils closer than ever before.
Ben said something there about being able to tell what colours dinosaurs were and about their feathers. I'd love to hear more about that.
Well, luckily for you, Michael, we have another Michael on the show, Michael Benton, who was part of a team that discovered a way to identify the colour of dinosaurs.
Hi, my name is Mike Benton. I'm a professor of paleontology at the University of Bristol. I'm really interested in all kinds of aspects of dinosaurs and the life of the past and mass extinctions. These are the things I study. And I think the most exciting aspects of these subjects is that there's so much new to find out. When I started, we were more or less told it's all been done and this is all in the deep past, this is hundreds of millions of years ago. You'll never know really what was going on. But we now have all kinds of exciting scientific methods of finding out those things. I've written about this in a book that's just been published called Dinosaurs, New Visions of a Lost World, which is aimed at anybody who is interested in finding out all the new discoveries.
As Mike explains, people thought there was no way we would ever be able to work out what dinosaur colours were like.
Colour of dinosaurs. This would have seemed impossible at one time. People would have said, you need a time machine, and there is no time machine, and nobody knows if there ever will be a time machine. We discovered the colour in the feathers of a small dinosaur from China called Sinosauropteryx, which means first Chinese reptile wing, something like that. And Sinosauropteryx was a small creature about 1 meter in length, and it was a flesh eater, maybe feeding on small lizards and insects. And when the fossils were found in 1996, they noticed that they were covered in fluff or a fuzz of short bristles all the way down the back and over the head, and patches on the body and all along the tail. And yet along the tail they looked as if they were in clumps and with gaps in between. And when we looked at these feathers and tried to reconstruct the colour, we discovered that the feathers contained a pigment called melanin, but a particular version of that which gives a ginger colour.
So hang on a second, what is a pigment?
So a pigment is a chemical that gives something its colour. So you have pigments in your hair and your eyes. So by seeing a particular pigment inside the dinosaur feathers, Benton and his team could work out what colour that dinosaur was.
So he said that they knew this particular pigment gave the dinosaur a ginger colour, but how did they work that out?
Well, do you remember what Cameron said earlier? One of the key things that paleontologists do is compare dinosaurs to modern day animals.
We could tell that this was the case because we compared the feathers with feathers from modern birds, where you can see the different kinds of melanin within the feathers are contained within structures called melanosomes of different shapes. In the dinosaur feathers, matching to the modern bird feathers, the melanosomes were shaped like little balls. Compared with the modern feathers, that indicates a ginger type of melanin.
So there are these structures called melanosomes, and they're like little capsules which hold the pigments inside the dinosaur feathers, yeah?
And these structures, these melanosomes, have different shapes depending on which colour they are.
So by comparing the melanosomes inside the dinosaur to those inside modern-day birds, that's how they realised that this melanin would have given it a ginger colour.
Exactly.
But how were Mike and his team able to look at the melanosomes?
That's where the electron microscope that Ben Garrett was talking about comes in. Mike had to use this special equipment because the melanosomes were so small.
These are tiny, tiny. They can only be seen under a scanning electron microscope. They're about 1 micron in size, which is 1/1,000,000th of a meter. And the melanosomes for the black-brown colours are shaped like little sausages. And the melanosomes for ginger colours are shaped like little balls. We found that all of the melanosomes were like little balls, which indicated that they contained the ginger type of melanin.
Wow, so that's how we find out what colour a dinosaur is. They discover some fossils and then, using some cutting-edge technology, they can take a closer look at them, all the while using modern-day animals as a reference point.
Yes, and that's not all. Michael and his team found out that this dinosaur also had a stripy tail and a banded white mask across its face.
That was maybe a kind of warning to other dinosaurs. Look out, I'm pretty mean. And what's the function of that stripy tail? Well, we think it's maybe something like in a peacock or a pheasant, where the male bird today has a very fancy tail, which it waves about to impress the females and encourage them to mate. And it may well be that a lot of these dinosaurs, including Sinosauropteryx, were doing just the same thing.
Okay, so we've learned what paleontology is and what paleontologists do. We've learned how new discoveries have changed our idea of how dinosaurs might have behaved, and even how new technology can help us find out what dinosaurs look like. But there's one very big, important question that our experts haven't answered yet.
What's that?
What's your favourite dinosaur?
Oh no, my favourite dinosaur. That's such a difficult question. It's the hardest one of all.
It's definitely hard for me to pick. I think Spinosaurus is a dinosaur that I grew up with. When I watched Jurassic Park 3, it was one of these vicious meat-eating dinosaurs that I learned in some of the books that I read. And just that fin on the top of its back really was curious. And no other dinosaur that we know of, or at least when I was a kid, no other dinosaur really had that particular structure on its body.
I change on a regular basis. I really do. So it's almost like a weekly thing. A few weeks ago, Ankylosaurus was my absolute favourite. I can still remember seeing not so long ago, just before the pandemic started, I was in the Natural History Museum and was lucky enough to see down in the stores an Ankylosaurus skull. I mean, they got a real special spot in my heart, the Ankylosaurs. I like the vegetarian dinosaurs. I'm a veggie myself, so I've got a real sweet spot for the veggies. Things like Triceratops and I think Dippy. Dippy is a firm favourite of mine.
My favourite dinosaur, I'll not give a single answer. Number one is Sinosauropteryx, which is the one where we were first to identify its colour back in 2010. Number two, though, I will give a call out for Thecodontosaurus. It's a long name, Thecodontosaurus. It was the fourth dinosaur ever named back in 1836, ever named from anywhere in the world. It was the first Triassic dinosaur to be named. I love the Triassic period. That's when dinosaurs originated, when the whole world was being kind of rebuilt after a terrible, terrible mass extinction at the end of the Permian. And Thecodontosaurus is commonly known as the Bristol dinosaur. So I'm located in the University of Bristol. And this thing was found within the city of Bristol, and we go out to schools around the city talking about it, introducing people to the study of geology and paleontology using this very British dinosaur. It's a small-sized plant eater, not very scary, but it was one of the first.
Well, we've heard from the experts, but how about you, Stevie? What's your favourite dinosaur?
Well, I've been researching this dinosaur at the moment called Supersaurus, and at 39 metres long, which is the same as 5 London buses, it is thought to be the longest dinosaur ever to have lived, and the longest animal ever to have lived, in fact. And I just find it fascinating.
Wow, well, first of all, Supersaurus, what an incredible name and what an incredible sounding dinosaur. I think mine is probably the Brachiosaurus, which I think is a sauropod, so one of the ones that Cameron was mentioning earlier, which have the long necks like giraffes. And I think I like that one so much because I think in the original Jurassic Park, that is the first dinosaur they see when they get to the park and they're kind of astonished to see this dinosaur brought back to life. And I remember being astonished when I was watching the film. So that was probably the kind of the dinosaur that in a way introduced me to dinosaurs in the first place and got me so interested in them. So that would probably be my favourite.
I love it. I love learning about these dinosaurs. So what about you guys? We'd love to hear what your favourite dinosaur is and why. Send us an audio or a video clip to hello@science-nature.co.uk and you could feature in a future episode of the podcast.
And don't forget, we'll be back in 2 weeks' time for our next episode, where we'll be travelling to Machu Picchu.
Sat atop a mountain in the Peruvian Andes, more than 2,000 metres above sea level, Machu Picchu is one of the world's most magical and mysterious places. But why was it built? Who lived there? And what happened to them? Join us and some expert guests as we travel to the secret city in the sky. Until then, stay curious.
Thanks for listening to The Week Junior Show, which is made by the same people that make The Week Junior magazine. You can get a free trial of The Week Junior by heading to theweekjunior.co.uk/podcast and using the code podcast at checkout.